Hello bright person and welcome to my video about playing with probabilities in World of Warcraft. This will be fascinating because firstly, players got a lot of options, just like when you were shopping for clothes. Secondly, what makes it more complicated is that some interactions between mechanics form a non-linear system, but the most popular approach for the optimization uses linear stat weights. To account for that, I am trying out a new approach by deriving the likelihood of success and maximizing it. And this is how we are going to do that. We will look at a time window, for example 1.5 or 3.5 seconds. After this time, we assume that the tank will get healed back up to 100%. For this single time frame, we compute every possibility and check which of those the tank would survive. For example, you can get hit 0, 1 or 2 times depending on your avoidance and the enemy's attack speed. Each attack deals random damage based on a specific range and can crit or crush. So we look if the tank survives, for example, 1 crush and 1 normal attack, and if yes, then the chance of this particular combination is added to the total chance of surviving within this time window. Then we can describe the whole encounter based on this time window and compute the total chance of success. Finally, we minimize the negative log likelihood and are done. Now we look at the simplified derivation of the likelihood. We need a tuple of damage d and the probability p that this amount of damage is dealt. This means that if we want to look at some combination of damage dealt, we add the damage and will have to multiply the probabilities. If we then have n attacks in a time window, then the probability to survive within this time frame is the sum of all probabilities pi1 to pin over all attacks i1 to in that deal damage di1 to din such that the total damage dealt is lower than the health pool of the tank. Since the whole encounter can now be expressed by capital N time windows, the total chance of success or likelihood is capital P to the power of capital N. From this, the negative log likelihood follows. As you can see, we now need to estimate the time of an encounter. For this, we first estimate the average damage dealer's DPS, considering the DPS is capped by the threat the tank generates, as shown by the first formula on this sheet. The threshold lambda depends on the class and is 109% for melees and 129% for ranged damage dealers. The coefficient C is the conversion coefficient between damage and threat and varies from spec to spec. Once we have the actual DPS, we can estimate the rate DPS and from that the time of the encounter. Now we need to estimate the TPS. We assume that the best result has the tank not rage starving, because else the encounter might take too long. If the algorithm should find such an item combination where the rage generated is insufficient, then this particular combination will be rejected. As for the rotation, we have to make some assumptions to speed up the calculations. First we replace all white hits with molds. Bangle is casted on cooldown of course, lacerate and raw debuffs are kept up perfectly, and the leftover rage is used for the higher threat option between swipe and lacerate. Now a few remarks. Firstly, an analytical solution is only available if we would discard the available items and buffs, so we might get the final stats but would not know if these stats are even achievable in-game. So, for all intents and purposes, the analytical solution is unavailable. Secondly, our likelihood may not be unimodal, what increases the computational power needed to solve it in realistic time greatly. Thirdly, and luckily, the number of item combinations is just slightly larger than the number of stars in our observable universe. Just to visualize this, here is a simulation of our observable universe. Now imagine that there is a multiverse with 10 to the power of 17 universes like ours. The number of stars in this multiverse equals the number of item combinations. And all these stars we would have to check with our formula. Only a minor inconvenience. We can solve some of these obstacles. First, we start with a random composition, half the time also including randomly chosen sets. Then we search for one single item that improves our likelihood the most and equip this item. This searching will be repeated until there is no single item left that improves the likelihood anymore. The resulting itemization and its negative log likelihood will be saved, and the procedure will be repeated often enough. The itemization with the lowest negative log likelihood is the final result. This plan sounds good, But it turns out that even using parallel processing and CUDA, it takes almost a week for one run, so we cannot analyze a statistically significant amount of data. But this obstacle can be circumvented by assuming that the available best-in-slot itemizations by other players are close enough to the optimal solution. These itemizations can serve as starting points. A few more things to consider when interpreting the result. First, the algorithm cannot plan more than one step ahead. It might be that the combination of two items improves the likelihood greatly, but individually these items have less impact than others, like set items for example. Secondly, we cannot guarantee the absolute best itemization there ever was and ever will be, because some testing showed the likelihood is not unimodal. Thirdly, the result will show the safest itemization, balancing offense and defense. It won't necessarily be optimal for speedruns or hardcore raiding guilds. Lastly, the optimization only holds true for one boss, since the likelihood depends on the enemy's stats. There are also a few specifics, approximations, quid pro quos I have to make that are all listed here. The most important part is that we will choose Prince Malchezaar as enemy and choose a 2.5 second window. Now we need to consider Thresh as well. What we are doing now is performing a simulation to determine the number of hits Malchezaar lands in 2.5 seconds based on effective attack speed, which includes also parry haste, and based on the player's avoidance. In red you can see the fit functions I found, and sharp eyes will see a little offset. I checked the values and they are closer than they appear, so the offset seems to be a graphical feature. One histogram is not fitted because we only need 6 out of 7 probability functions. The other is just 1 minus the rest, and this particular fit function had the worst chi-square. You might wonder why I chose such a large time window for this difficult phase. Surely no item combination can make the player survive 6 hits. And I say that you are right, there is no such combination, but my name's not Shirley. It is a little experiment because the only chance to survive this is to increase avoidance and hope for the best. So we will see if an avoidance tank, a stamina tank or even off tank will be preferred by the algorithm. Finally we arrive at our likelihood. Here we compute the chance to survive phase 2 with n time windows of 2.5 seconds each, with the probability Qj that j attacks occur multiplied by the probability Pj to survive these many attacks. Then we consider that you can get ij times j attacks during the whole second phase, so we take the corresponding probabilities to the power of ij. Then we need to consider all possible permutations, so we also have to include the multinomial. The likelihood is then the survival chance of each phase multiplied. Let's first look at the itemization for a Night Elf, because there are slight differences and the Night Elf scored lower than the Tauren. Some differences are due to Wowhead using items from all phases, while we limit the use to phase 1. The single best item that the algorithm always picks first is the Earthwarden. Surprisingly, the agility enchants are never chosen. The single best shoulder enchantment is of course the Fortitude of the Scourge, but might be difficult to obtain for many. The next best alternative is an offensive enchantment. The gems used are stamina and hit rating gems, while the gem boni are just a cherry on top. The Cleft-Hoof set was chosen because every time these items are on their own already better than every alternative. Next is the Tauren. The itemization is the same in all but one regard. The back enchantment provides now fire resistance instead of armor. The fire resistance was picked because we assumed that during the entire duration of the first and third phases the player has to take damage from one infernal. This is usually not the case, and the enchantment can therefore be replaced with the armor enchantment. Interestingly, only the Tauren got this, which might be because the additional 700 HP enlarged the range of attacks the druid survives just enough that the non-scalable armor enchantment loses effectiveness compared to the fire resistance. It is likely that there is another inflection point where the algorithm achieves the minimal HP and armor requirements to survive, for example, 4 hits. Once this point is reached, then armor should become more important again, but as long as the player can survive J but not the weakest J plus 1 attacks, then it makes more sense to optimize the other phases. The biggest surprise is that agility and dodge are so neglected. When I replaced the engineering trinket for the Darkmoon card Vengeance, the algorithm said that dodge becomes even counterproductive. The little bit of threat increase is much better than dodge, despite the fact that increasing dodge decreases the expected number of attacks linearly. And even under the assumption that Thrash cannot proc from an avoided hit, making the number of expected hits fall even faster, dodge is still not worth the decrease in threat. So, according to the algorithm, it is better to avoid damage by killing the enemy faster, for which it needs hit and expertise rating, not crit. The algorithm also computed the best consumables. Both races get the most from the Flask of Relentless Assault, but buff loot is different. Night Elf profits from Spicy Hot Talbuk, while the Tauren needs Spicy Crawdad. Finally, you might like to know the numerical values, the likelihood. Negative log likelihoods for the online pre-raid best in slot itemizations were larger than 40. The final result for the Night Elf was 37.424 and for the Tauren 36.955. And this means rhetorically, poetically, practically and in every other fancy way a success rate of 0% if there is only one player healing the tank during phase 2 and the tank does not get any raid buffs. If one or two healers can get the tank back to full life every more or less 1.75 seconds, already including parry haste, then the success rate should skyrocket. I hope you enjoyed this video. Leave a like if you did, write in the comments any open questions and critiques. Have a nice day.